R1. And what have I got for R1? I know that it's 25 ohms. And R2 we don't know. Okay. So the circuit consists of parallel batteries, or parallel branches, pardon me. When the switch is closed, the current is increased by 50%, which would make sense. As you increase this, as you increase a branch, it's going to get more. And so what I did is, it doesn't say what the EMF of the battery is, but I like to just put numbers in. So I like to just, if I'm making numbers up, it's going to make my life easier, I feel, if I just increase that. Let's call it 50. You'll see why I did that. So the total current, so I said an open switch, I can say, V equals IR, 50 equals I times 25 plus, and R2 and R2 are the same. I'll just call it X. I'm solving for X. Okay, now I have an I and an X, so I'm not done, right? And that is the first situation, right? And that's the total there. When I close the switch, I can say 50 equals I, but it's actually I know I is. They say it's going to be 50% more, so I'm going to say 3/2 R, or maybe I'll say 1.5 I times R. R will be 25 plus 1 over X plus 1 over X to the minus 1, right? Now, as it turns out, now that I look at this, what I could do, I could set these two equations equal to each other, and I've got some things that can cancel out. The 50s actually, doesn't matter, will cancel. So I can say I total times 25 plus X equals 1.5 times I total times 25 times 1. Actually, I can just say 2 over X to the minus 1. The I's cancel, don't they? So I can say 25 plus X equals 1.5, and then this would be 25, this should be a plus here, times the quantity 25 plus X over 2. And I solve for X, and you'll get the right answer.